All right, this next topic is a little bit more involved. It's going to be about taking the second derivative of embedded functions. So kind of like the chain rule from Calculus 1, except it's going to be a bit more involved, and it's going to involve the product rule as well. So just a caveat, you can only take the chain rule for one of the variables at a time. So to explain what I mean by that, you're going to have a function, an outermost function, let's say it's z, and then two inner functions. Let's say that those are r and theta, and then two innermost variables of those inner functions, which are s and t. So you can only do this for one of those innermost variables at a time. So essentially what we're trying to do then is take the second derivative of z with respect to, say, t. And then s we're just ignoring completely, and you'd have to redo this entire process over if you want to do s. Okay, so first step, you're going to take the full derivative of z, and that's of course with respect to t. So this part is similar to the Calculus 1 chain rule, except for the fact that we do it twice, getting two terms that we are then going to sum. So we have the derivative of z with respect to t times the derivative of r with respect to t. So that's a chain rule. And then you sum that with the next term, which is going to be the derivative of z with respect to theta times the derivative of theta with respect to t. And take in mind for this entire problem that we use the full derivative symbol when we're doing z with respect to t, but when we do the intermediate functions, anything involving r or theta, whether it's on the numerator or denominator, we're going to use the partial derivative symbol, in other words, the curly d, when we're writing it, because that part is not capturing the full derivative. Okay, so anyways, the second step, once you get that sum that I just mentioned, is to take another derivative with respect to t. So in other words, you're going to put a regular d dt of everything that we just did in step 1. So the answer to this is conceptually pretty easy because you're just using the product rule as opposed to the chain rule from step 1. That being said, it's pretty long to write it all out. So there's going to be two major terms here. So the first thing that you're going to do is the product rule, L times derivative times dr plus r dl. So the left times the derivative of the right plus the right times the derivative of the left. So applying that to the first term from that first step, you're going to have the derivative of z with respect to t, which is the left, times the second derivative of r with respect to t, which is, the dr, and then add to that the r dl, which is the derivative of r with respect to t times the derivative with respect to t taken on the derivative of z with respect to r. So that was all just for the first term. Now applying it to the second term, we're going to have the derivative of z with respect to theta times the second derivative of theta with respect to t, and then add to that the derivative of theta with respect to t times the derivative with respect to t taken on the derivative of z with respect to theta. So hopefully you can visualize that, otherwise you're screwed.